Friends, how to write and balance chemical equations. Chemical reactions are expressed by the chemical equations using symbols of elements and formulas of compounds. In a chemical reaction, one or more reactants react to yield one or more products. In this video, I shall discuss how to write a chemical equation for any given chemical reaction and how to balance the chemical equation. Consider a chemical reaction between carbon and oxygen which gives carbon dioxide. First we write the word equation. Carbon within brackets S plus oxygen within brackets G, arrow carbon dioxide within brackets G. The chemical equation for the above word equation can be written as C, that is symbol for carbon, within brackets S, plus O2 within brackets G, arrow CO2 within brackets G. That is how we write the chemical equation. Reactants are always shown on the left hand side, products are always shown on the right hand side. Plus sign is used to link the one or more reactants or one or more products. Arrow is shown to indicate the direction of the reaction. S for solid, L for liquid, and G for gas. According to the law of conservation of mass, mass can neither be created nor destroyed. Therefore, the number of atoms of each element of all the reactants put together must be equal to the number of atoms of each element of all the products put together in a balanced chemical equation. Now let us examine the equation 2. Element C, both sides 1. Element 1, both sides 2. Therefore, equation 2 by itself is a balanced chemical equation. Consider another chemical reaction between magnesium metal and oxygen to form magnesium oxide. First we write the word equation. Magnesium within brackets S plus oxygen within brackets G gives rise to magnesium oxide within brackets S. The chemical equation is Mg plus O2 giving rise to MgO. So now if you see whether the reaction is balanced or not, Mg is balanced, but oxygen is not balanced. Left side 2 atoms, right side 1 atom. So this kind of equations are called skeletal equations. This is skeletal equation. We have to balance it. Right? To balance O, multiply MgO on right hand side by a coefficient of 2. Then it becomes 2MgO. Now O is balanced, but Mg balance is disturbed. To balance Mg, multiply Mg on LHS by a coefficient of 2. Then it becomes 2Mg. Then the equation becomes 2Mg plus O2 gives rise to 2MgO. It's a balanced chemical equation. Consider another reaction between zinc metal and sulphuric acid. First we write the word equation. Zinc solid plus sulphuric acid aqueous giving rise to zinc sulphate aqueous plus hydrogen gas. The chemical equation is Zn within brackets S plus H2SO4 within brackets AQ giving rise to ZnSO4 within brackets AQ plus H2 gas G. Now see whether it is balanced or not. Let us check. Zn balanced, H2 and 2 balanced, S 1 and 1 balanced, O, 4 and 4 balance. So that means equation 7 is a balanced chemical equation. Now consider another chemical reaction between sodium hydroxide aqueous and sulphuric acid aqueous, which produces sodium sulphate aqueous and water. First write the word equation. Sodium hydroxide AQ plus sulphuric acid AQ gives rise to sodium sulphate AQ plus water liquid. Now the chemical equation is NaOH AQ plus H2SO4 AQ giving rise to Na2SO4 AQ plus H2O liquid. Let us examine whether equation 9 is a balanced equation. You see, sodium is not balanced, LHS1 or HS2. H is not balanced, LHS3 or H2. S and O are balanced. So we have to balance both sodium and hydrogen. Now, to balance Na atoms, multiply NaOH on LHS by a coefficient of 2. Then equation 9 becomes 2 NaOH plus H2SO4 giving rise to Na2SO4 plus H2O. Now, to balance H atoms and O atoms, multiply H2O on RHS by a coefficient of 2. Then the equation becomes 2 NaOH plus H2SO4 giving rise to Na2SO4 plus 2H2O. It is a balanced equation. Now let me explain some general guidelines for writing and balancing chemical equations. First one, the physical state of each of the reactants and products may be mentioned within brackets for solids S, liquids L, gases G, aqueous solutions AQ. Number 2, the conditions of the reaction like temperature, pressure, sunlight, catalyst, etc. where applicable must be mentioned above or below the arrow. Number 3, there must be the same number of atoms of each element on the left side and right side of the chemical reaction. Guideline 4, very important sir, guideline 4. It is often convenient to start balancing with the compound that contains highest number of atoms either in the reactants or in the products. Again, in that compound, select the element that contains the highest number of atoms. Please remember this guideline 4 always. Now 5. Add coefficients only before any element or compound. Do not change the formulas. Balance any single element species last. Now consider another chemical reaction in which iron metal in red hot condition reacts with steam to produce iron 2,3 oxide plus hydrogen gas. First the word equation, iron in red hot condition plus steam, iron within brackets 2,3 oxide plus hydrogen. The chemical equation is FeS plus H2OG because it is steam. High temperature, 500 degrees centigrade, 600 degrees centigrade like that. It gives rise to Fe3O4 solid plus H2 gas. Now let us see whether it is balanced or not. Iron, Fe is not balanced, LHS1 or HS3. H is balanced. O is also not balanced, LHS1 and RHS4, 4 atoms. Therefore, we have to balance it. Now, as per the guideline 4, we have to balance oxygen atoms first. How can we do that? By multiplying H2O on LHS of equation 13 by a coefficient of 4. Then the equation becomes Fe plus 4H2O giving rise to Fe3O4 plus H2. Now we have to balance Fe and H atoms. Fe can be balanced by multiplying Fe on LHS by a coefficient of 3. H can be balanced by multiplying H2 on RHS by a coefficient of 4. Then equation 14 becomes 3Fe plus 4H2O giving rise to Fe3O4 plus 4H2. Check once again the number of atoms of Fe, H and O on LHS and RHS. Equation 15 is a balanced chemical equation. Now consider another chemical reaction between carbon dioxide and water in the presence of sunlight and chlorophyll. First write the word equation: carbon dioxide plus water, sunlight and chlorophyll. Sunlight is necessary, chlorophyll is a catalyst necessary. Products are glucose and oxygen. The corresponding chemical equation is CO2G plus H2O L giving rise to sunlight, in the presence of sunlight and chlorophyll, giving rise to C6H12O6 solid plus O2 gas. Now we have to balance this equation. Again look at the guideline 4. So then we have to start balancing H. This can be done by multiplying H2O on LHS by a quotient of 6. Then equation 17 becomes CO2 plus 6H2O gives rise to C6H12O6 plus O2. Now balance C by multiplying CO2 on LHS by a quotient of 6. Then we have 6 CO2 plus 6 H2O, C6H12O6 plus O2. Now balance O by multiplying O2 on RHS by 6. Then equation becomes 6 CO2G plus 6 H2O gives rise to C6H12O6 plus 6 O2. Equation 20 is a balanced chemical equation. Now self-assessment quiz. Consider the chemical equation MnO2 solid plus XHCl gives rise to MnCl2 plus YH2O plus ZCl2. In order to balance the above chemical equation, the values of X, Y and Z respectively are 221, 412, 241, 421. You have to select the appropriate option and put it in the brackets. Which of the following chemical equations is a balanced equation? I have given 4 options: ZnS plus HCl, ZnCl2 plus H2, Mg plus O2, MgO, NaOH plus HCl, NaCl plus H2O, Na2CO3 plus HCl, 2NaCl plus H2O plus CO2. Which of the following chemical equations is not a balanced equation? CaCO3, heat, CO plus CO2, CO plus H2O under 340 atmospheres pressure, CH3OH, Fe plus CuSO4, FeSO4 plus Cu, 2Cu plus O2, heat, 2CuO solid. Now fourth, consider the equation XCl2 plus YNA3PO4 Ca3PO4 twice solid plus 2NaCl. In order to balance the above equation, the values of X, Y and Z respectively are option A 2, 3, 6, then B 3, 3, 2, C 3, 2, 6, D 2, 3, 2. Choose the correct option. Now conclusion. Practice balancing many more unknown chemical equations by following the guidelines given above and steps explained above in so many examples. Then you can balance any given unknown chemical equation accurately and quickly. Both are important. This is the skill you have to master. Remembering so many balanced equations is a wrong approach to achieve the mastery of knowledge in balancing chemical equations. I wish you the best of your efforts in mastering knowledge.